All right. How do you explain solubility of ionic compounds in water? Okay. When you put an ionic compound in water, okay, they would tend to dissolve, and the reason for the dissolution is that your ions can have strong attractions for water molecules. So if I have a positive ion, which part of the water molecules would be attracted to it? The oxygen end or the hydrogen end? The oxygen. So an oxygen here would be attracted to that, right? So that is what we would call an ion-dipole interaction. The ion is attracted to your water molecule, which is a dipole, polar molecule. Okay, so your positive ions would be surrounded with water molecules, with the oxygen end of your water molecules attracted towards the positive ion. What about your negative ion? Which end of your water molecules would be attracted to it? The hydrogen end of your water molecules would be attracted to it. So those types of interactions are called ion-dipole interactions. However, you'll find, okay, in fact, you've learned about solubility rules for common ionic compounds. There are some ionic compounds, or a lot of ionic compounds, in fact, that are not soluble in water. Why is that? Well, the reason is, although the ions interact strongly with water molecules, they can mingle with the water molecules. In some cases, the positive and the negative ions, since they attract each other anyway, in some cases, the attractions among the positive and the negative ions are so strong that they'd rather be by themselves. Okay? So, remember, in an ionic compound, what do you have? You have positives and negatives right next to each other, right? There's very strong attractions holding those ions together in the solid. For them to actually spread out in the water and be surrounded by water molecules, the first thing you need to do is break those ionic bonds between them. So in some cases, those ions, the attractions among the ions themselves are so much stronger, they'd rather be by themselves than mingle with the water molecules. So you need energy to separate the ions in a solid. So the energy you need to separate these ions, okay, from the solid to the gas phase, that's known as the lattice energy. The lattice is the, when you look at this structure of a solid where you have plus minus arranged in a regular pattern, that pattern is called a lattice. Just like when you have a lattice pie, you have that structure shown, right? So if you have a regular arrangement of positives and negatives, positive, negative, you have what's called a crystal lattice. So you're looking at a competition then between ionic bonding in the lattice and ion-dipole interaction. So in some cases, the lattice energy is so strong, okay, that your ionic compound ends up being insoluble in water.